Okay, so there's another problem we're going to take a look at. A 7.7 ohm resistor, a 11.9 ohm resistor, and a 16 ohm resistor are connected in series with a 48 volt battery. Calculate the equivalent resistance, all right? This is one where there's no diagram given, so we're going to have to interpret what is written. We have a battery, which we're told is 48 volts. Great. We say that in series is a 7.7 ohm, an 11.9 ohm, and a 16 ohm. Now you could draw this any way you want. You could have 1, 2, 3. You could have any combination here. But the important thing is these are all in series. Current comes out of the battery, goes through this one, goes through that one, goes through that one. Since the same current is going through all of them, or more accurately, the current going through this goes through that one, we could establish that these are all in series. This was a 48 volt battery. This is 7.7 ohms. This is 11.9 ohms, and this is 16 ohms. Now I'm going to do this one a little bit more quickly. I think we're kind of adapting to this. First question is, what is the equivalent resistance? Well, these are all in series, so we just add them up. 7.7 plus 11.9 plus 16. As a reminder, when they are in series, the equivalent resistance is equal to R1 plus R2 plus R3 plus ... however many resistors you have. If they're all in series, we just add them up, and we come up with 35.6 is my equivalent resistance, and that is exactly what is listed as the answer. Okay? Then they ask, what is the current in each resistor? Here is where we could go through, we could redraw this, we could do a bunch of things, but we do know that if I were to draw this out, it would look a lot like this. We could replace all three of these resistors with one equivalent resistance, which we said was 35.6, oops, not volts, ohms. We have a 48 volt battery. So the total current coming out of the battery, we would apply Ohm's law, which is delta V equals IR. For the total circuit, we know that the total resistance is 35.6, and the total potential difference supplied by the battery is 48. So if I take 48 divided by 35.6, I will find that the current that we are getting, the total current coming out of the battery, is 1.348 amp. And if that is the current coming out of the battery, that is the current that goes through the 7 ohm, through the 11.9, and through the 16 and back into the far side of the battery by Kirchhoff's junction rule. As a result, our correct answer should be 1.348, and let's see, that is exactly what we have listed. Now the question is, if the resistors are instead connected in parallel across the battery, what is the equivalent resistance? Well, that might sound a little bit crazy, but what they're actually asking is this. I'm going to draw this out for you so you've got an idea, and then I'm going to leave this to you all to actually solve it. We're taking the same resistors, but we're attaching them in parallel in our circuit. It's basically what they're saying. And so we have a 7.7 ohm, we have an 11.9 ohm, and we have a 16 ohm. All three of these are in parallel. And as a reminder, for parallel, 1 over the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over ... however many you have. We could have a million. We only have 3 in this case, so you can kind of ignore this part. But I'd do 1 over 7.7 plus 1 over 11.9 plus 1 over 16, and that, all of those added together will be 1 over the equivalent resistance for this circuit. We'd still have a 48 volt supply. Find the equivalent resistance, find the current coming out of it, and you can start working with that. First question was find the equivalent resistance. And the second question is what is the current in the 7.7 ohm resistor? So they'd ask how much current goes through here. I'm going to give you a tip. Apply loop rule. We get 48 here, go around this loop, we lose something, and then come back to 0. You actually know the potential across the 7.7 ohm resistor. They also ask, what is the current in the 16 ohm resistor? Well, look at that. It's in parallel with the other, so it will also have a 48 volt, oops, gave it away, 48 volt drop. Double check that you're familiar with how to solve those, but hopefully this is something that you've got down pretty well by this point. So, take a look at that. I'm actually going to stop here because I've drawn this out, giving you a heads up in how you can go about solving these. Feel free to use here's one from a previous video, our table approach, which works really well for complicated circuits, and then see what you can come up with on this.